In the previous chapter, we showed that the transfer of heat between two objects results from an exchange of internal energy between them. In this chapter, we want to study several different ways in which this transfer of heat can occur. To begin, let's consider what happens when we heat a fluid. Consider the air just above a campfire, for example. As the air heats up, it expands, causing its volume to increase and the density of the air to decrease. According to Archimedes' principle, the surrounding cooler and denser air applies a buoyant force to the warmer air, pushing it upward. The cooler air that moves in to push the warm air upward is then warmed itself, and then it too moves upward. Thus, a continuous flow of air is created which carries heat along with it. Whenever heat is transferred by the bulk movement of a fluid, the heat is said to be transferred by the process of convection, and the fluid flow itself is called a convection current. The photograph below shows a plume of smoke rising from the Deepwater Horizon oil drilling platform in the Gulf of Mexico in 2010. Equipment on the platform failed, causing an explosion and fire. The plume of smoke rises hundreds of meters into the air due to convection. Another example of convection occurs when the ground is heated by the sun's rays, which warms the layer of air directly above the ground. The surrounding cooler air pushes the warm air upward. This resulting updraft of air, or a thermal, can be quite strong. In fact, glider pilots can gain considerable altitude by riding the thermals. As a final example of convection, consider the wind chill factor, which is often mentioned in weather reports. The wind mixes the cold ambient air with the warm air near the surface of your skin. This forced convection removes heat from the exposed body surfaces, thereby making you feel colder than you would if there were no wind.